The kidneys are part of the urinary system. That will be the major focus of this chapter. The kidneys, along with the bladder and the ureter, are important for removing nitrogenous waste. So they are a major part of the homeostasis for the composition, pH, and volume of body fluids and keeping them within normal limits. The urinary system removes metabolic wastes and substances present in excess, including foreign substances, which might be drugs or metabolites of drugs. The urinary system consists of the kidneys, which filter blood to form urine, the ureters, which transport that urine from the kidneys to the urinary bladder, the urinary bladder, which collects and stores the urine, and the urethra, which conveys urine from the urinary bladder to the outside of the body. They are shown here in an artist rendering and a medical image. Kidneys are reddish brown. They're kind of bean shaped. They have smooth surface all around. You'll see that on Thursday when you dissect some. In the adult, it's about 12 centimeters long, 6 centimeters wide, 3 centimeters thick, and it is enclosed in a tough fibrous capsule. They lie on either side of the vertebral column with a high in the depression of the posterior abdominal wall. The kidneys are retroperitoneal, so they are behind the peritoneum. The left kidney is about 1.5 to 2 centimeters higher up than the right kidney. Again, the kidney is surrounded by connective tissue called renal fascia, and there are masses of adipose tissue there as well. And also recall that on top of the kidneys sit the adrenal glands. So more images you should go through in your book as you're reading. So we have a convex lateral surface and a concave medial surface. The renal sinus is the hollow chamber in that medial depression. The hilum is the entrance to the renal sinus. That's where we saw hilum in the lung as well. Renal pelvis is a funnel-shaped sac. Superior, it's the superior end of the ureter. The major calyces are large tubules that merge to form renal pelvises. The minor calyces are small tubes that merge to form major calyces. So we go minor calyces, major calyces, renal pelvis. Renal medulla is the inner region composed of renal pyramids. The outer is called the renal cortex. Renal columns are extensions of the cortex that dip into the medulla. The renal capsule is a fibrous capsule around each kidney. And the functional unit of each kidney that we're going to talk a lot about today, where urine is produced, is called a nephron. And those are all demonstrated here. And this gives you an anatomical view of where the kidneys are. So the renal artery enters each kidney through the hilum and continues to branch to the nephrons. We follow it through. We have a renal artery, interlobal artery, accurate or archiform artery, cortical radiate or interlobular artery. Afferent arteriole goes into each nephron. The glomerulus is the capillary network that filters the blood within the nephron. The efferent arteriole takes that blood, and then we have peritubular capillaries. From the nephron, the venous blood returns to the renal vein through the cortical radiate or interlobular vein, the accurate vein, the interlobular vein, till finally the renal vein. And those are demonstrated here. Within each nephron, blood is going to go afferent arteriole, glomerulus, efferent arteriole, and peritubular capillary. So we've got a glomerulus between two arterioles, a little different structure than we've seen anywhere else. So if we follow that pathway again from the beginning, going into the kidney to coming out, we would go renal artery, interlobular artery, arcuate artery, cortical radiate, afferent arteriole glomerular capillary, efferent arteriole peritubular capillary, or the vasa recta, which we'll talk about later on, to the cortical radiate vein, the arcuate vein, the interlobular vein, to the renal vein, and out of the kidney. So the real working units of the kidney are the nephron, and each kidney contains about 1 million functional nephrons. Each one is composed of two major parts, a renal corpuscle, which includes the glomerulus. The glomerulus is the cluster of capillaries that filters the blood. That's the first step in urine formation. From the afferent arteriole, blood goes through the glomerulus and then makes its way to the efferent arteriole. The glomerular capsule, also referred to as Bowman's capsule, receives filtrate from the glomerulus. Renal tubule extends from the glomerular capsule to the collecting duct. Its filtrate proceeds from the glomerular capsule to the proximal tubule to the nephron loop, which is also called the loop of Henle, and it's composed of a descending and ascending limb. Finally, we reach the distal tubule. Distal tubules of several nephrons empty into collecting ducts, and those continue through the medulla and join other collecting ducts that drain through the renal papillae into a minor calyx. So here is a renal corpuscle, which consists of a glomerulus and a glomerular capsule. Here is the glomerulus. This structure around here is the capsule. And that's the site where blood is filtered in the kidney. So if we look at an intact nephron, we've got this capsule structure. We've got the glomerulus here surrounded by a capsule, which goes to a proximal convoluted tubule, lots of twist, to a nephron loop, and then to a distal tubule, which would drain into a collecting duct. That's the site of urine production. It's a renal corpuscle and a renal tubule, and the blood vessels associated to that are quite unique in structure to, and function for that matter, to the kidney. We don't see these anywhere else. And we look at them microscopically. Here we see a very nice image of the renal cortex with a glomerulus surrounded by its glomerular capsule. Harder to make out the renal tubules and the nephrons, but they are there. All right, that covers sections 1 and 2. I'm going to stop there.